Okay, so today you are going to be doing exercise 2I, which is on simultaneous equations with substitution. So simultaneous equations essentially are two linear equations that are happening at the same time, hence simultaneous. So what happens when two equations are happening at the same time, or two straight lines, is that at some point in time they are usually going to cross paths. So the point of solving simultaneous equations is to find that point on the graph where your two lines cross each other. What we call that is your point of intersection. So when you find your answer, which is a point of intersection, it is actually a coordinate. So it's the value of your x and your y variable at that point where your two graphs cross paths. So to solve simultaneous equations, there are two methods you will be using. The first one for this exercise is substitution, and the second method is called elimination, which you will do in the next exercise. So when you are solving simultaneous equations with substitution, what we are trying to do is essentially put the value of one variable into another equation. So usually you'll see that one equation is y equals to something or x equals to something, because that tells us the value of x and y. So for example, if we have x plus y equals 10, and we call that equation number 1, and equation number 2 is y equals 4x. You'll see that if y equals to 4x, that means that any value of y is the equivalent of 4x. So what that means for us is that we can put the value of y equals to 4x from equation 2 and substitute that into equation 1. So wherever we see a y in equation 1, we will replace that with 4x. So that becomes x plus, and instead of y we put 4x equals to 10. So that means that we only have x's in our first equation, and then we can solve for that value of x. So once we've expanded the bracket, you'll see that x plus 4x is 5x equals to 10, and x is just equal to 2 when we solve for x. Once you solve for x, well then we can just substitute that into either of the equations. I'm going to substitute it into equation number 2 because it's y equals to 4x, and then we can find the value of y. So that makes the equation y equals to 4, and instead of x, we replace it with 2, which means y equals to 8. So your point of intersection, or the point on the graph where your two lines cross, is at the coordinate of x is 2 and y equals 8. So we write that in coordinate form of 2, 8, both in brackets. So that's a point of intersection. So let's try another example that's got two different equations. So our first equation is 4x minus y equals 6. And our second equation is y equals to 2x minus 4. So let's label our equations 1 and label equation number 2. So in the second equation, you can see that y equals to 2x minus 4. So what that means is if we were to substitute equation number 2 into equation number 1, that means that wherever we see a y, we can write 2x minus 4 instead. So the first equation becomes 4x minus 2x minus 4 in a bracket equals to 6. So be careful when you're expanding a bracket because of the negative. That will change the sign on the once you've expanded your values. So minus 2x plus 4 equals 6, and then we solve for x. So 2x plus 4 equals 6, 2x equals to 6 minus the 4, 2x equals to 2, and x equals to 1. Once you have found the value of x, again, you substitute that into any of the equations. We're just going to substitute it into equation number 2 because it's y equals to something. So once we substitute, we can solve to just find y. So when we substitute x equals 1 into equation number 2, we have y equals to 2. In a bracket, we replace it with a 1 minus 4. So y equals to 2 minus 4, and just y equals to minus 2. So your point of intersection in this case is 1 and -2 in a coordinate, and both of those values in brackets. When you are substituting values into simultaneous equations, what you'll notice is that I have essentially written what I'm going to do. So writing sub something into something, or sub 2 into 1, or 1 into 2, helps you to go back and identify the steps that you've done. In both of these examples, we happen to solve for x first. It is possible to solve for y first. So it just depends on which equations you have been given. What I would recommend for you to do is to try and watch this video again and play it slowly, follow the steps, and then try some of the examples on your own before you try the exercise.